lecture. So, ladies and gentlemen, I want to thank you very much for all your dedication so far for ICT712 Information Technology Project Management. Is anybody here with me today in this lecture for the first time? Is anyone here the first lecture with me? Okay, great. Now, ladies and gentlemen, we started speaking about information technology project management. We started the first week talking about what is project. We started talking about information such as what sort of strategy we need to use to go and choose the right project. We then started talking about things such as the culture of the organization. We spoke about work breakdown structures. We spoke about all of these initial topics that we go through to really introduce the project management for you guys. Today, what I'm going to do is we're going to go and start drilling into all the technical calculations relating to project management. So you're going to notice this week, next week, you're going to notice calculations going to keep on flowing for you. And what I can tell you from now, the calculations that I'm going to be covering in the tutorial and the calculation that I'm going to be covering in the lecture are going to be relevant for your first quiz that is going to be coming up next week. So your first quiz is next week, and the calculation that I'm covering are relevant. Any other calculations I'll be covering will be relevant for future quizzes, as well as for your final exam, definitely. So if you do not come to your lectures on time and every week, you will find it very difficult to absorb those calculations. The calculations are continuous. The first calculation out to the next one to the third one, and so on. So what I want to ask you now, do me one favor. If any of your friends are not here, they're not logged into the classroom, message them now. Let them know how important it is for them to be able to go and be attending the lecture with me in the next 3-4 weeks, especially because these calculations we're covering, if they're not going to be able to go and learn them, it's going to make it difficult for them to be able to go and pass the quizzes that we are going to be allocating for each of you. So I'm going to start today talking about estimating project times and costs, and we're going to talk about developing the project plan, where we start talking about the network diagram, and you will need to draw those diagrams yourself, and you will need to calculate all of this information relating to those diagrams yourself. So the learning objectives, ladies and gentlemen, for today, we're going to understand estimating project time and cost, how they are the foundation for really planning projects and controlling projects. We're going to describe the guidelines for estimating your cost, estimating your resources, estimating all of your time. And we're going to go and also describe the methods, uses, and advantages and disadvantages of using what we call a top-down estimating method or a bottom-up estimating method. We're going to also distinguish between different kinds of costs associated with a project. We're going to suggest a scheme for developing an estimation database for future projects. We're going to understand the challenges of estimating mega projects and describe steps that lead to better informed decisions. We can understand the linkages between the work breakdown structure that we started talking about last week and we introduced last week. And we had an exercise about last week in the tutorial and the project network. We're going to diagram a project network using the AON method, activity on node method. And we're going to calculate early start, late start, early finish, late finish, and slack activity times, which are really essential for your final exam. And they are essential for your quiz also, and they are essential for everything you're going to be doing in terms of calculation for the next few weeks. We're going to identify and understand the importance of managing the critical path. The critical path is the path that you will be able to identify, and any project activity that is on that path, if it gets delayed, it will delay the ability to go and deliver the project. So we're going to go and learn about that. We're going to distinguish free slack and total slack. What's the difference between both of these? Now, someone sent me a question in the chat to say what kind of question will be in the quiz. The question will be, all of them are multiple choice questions. However, a number of those multiple choice questions are actually calculation questions that you need to go and have a pen and a paper to draw them yourself to be able to get the answer. So although they're multiple choice, there is calculation multiple choice also as part of those questions. Now I'm gonna just pause this question again now. I'm gonna name some names. If anybody of those names are here, please let me know. Shima Navneet Kaur, Abhishek Giri, Muhammad Ramzan Akram.
Yes, I'm here.
Who's that?
Abhishek Giri. Abhishek Giri.
Perfect, okay. Muhammad
Yes, sir. Thank you.
Ramzan Akram, Nikki Shrestha, Bishal Rawood, Sukhbir, and Abdul Rahman. Okay, no one else? No worries. Abhishek, please make sure you come to every lecture and tutorial because what I'm covering from now on is really, really important.
So yes, sir. Sorry, sir. I just joined in this week. I started from this week. I was missing 2 weeks.
Welcome.
I was 2 weeks behind, sir. Sorry.
Big welcome.
I'm here, Abdurrahman. I also joined in this week.
Perfect, my friend. Please make sure you're coming every week from now on because they are important. We don't want you to miss any calculations, my friend.
Okay, no worries, sir. Thank you so much.
Welcome. Welcome, guys. Well, let's start, guys. So, how long will your project take if I add 2 people? Well, add 1 month for training, 1 month for the extra complexity, and 1 month to deal with everybody's drama. But after all of that, they'll be as useful as this meeting, okay? So we go and add a lot of people to the project. We go and add people. We think if we add more people, it's going to be making the project more efficient and we're going to be able to go and deliver things better. The truth is, ladies and gentlemen, if you go and get more people, it does not mean you are going to be operating in a more efficient manner. It just simply means it's adding a lot of complexity. You need to have enough people, but not too many people that are making your project and your ability to go and deliver things unable to go and deliver the expected outcome. So you need to make sure you have enough people that are operating in an efficient manner. We started talking last week about the work breakdown structure. Could anybody please tell me what is a work breakdown structure? Does anybody remember what is a work breakdown structure? My friends, what's the work breakdown structure? We did it last week.
The work that already finished.
It is
No,
about
that's
setting
the
milestones
milestone, my friend.
and deadlines and milestones.
So what is it? Could you just explain to me what is a WBS? So what is it? What is it actually?
So it's like breaking down the project into small.
So if I tell you I would like to go and build a house, what is a work breakdown structure?
There should be some milestones. First of them will be buying a plot and then hire some labor.
Okay, I'm going to try to show you something that I showed you last week.
Yeah.
That really relates to that. Just give me 1 second. Okay, I'm going to open last week because we've worked on an exercise. Weekly tutorials, week 2, tutorial 2. Okay, I gave you a work breakdown structure exercise last week. Can you guys see my screen?
Yes,
sir.
I said, we want to open a tutoring center. And I said, what tasks do we need to do to open a tutoring center? And you told me, we need to register a business, we need to recruit employees, we need to select a location, we need to design an office, and so on. And then we said, okay, we're going to register a business. What do we need to do to register a business?
Yes, sir.
We need to speak to an accountant, apply for an ABN, other. And then at the end, I said, business account registered. What did I say business account registered is?
It's a milestone.
It's a milestone. So all of this, what is that called?
WBS.
Work breakdown structure. All of these high-level tasks and sub-level tasks required for us to be able to go and create and deliver one specific project. So that's what a work breakdown structure really is all about.
So it's like breaking the project into different parts and components.
It's breaking the project into all of these small components that needs to be done in order for us to be able to go and deliver the project.
Yep.
That's all what it is. Does that make sense?
Yes,
Yes, sir.
Okay. Now, ladies and gentlemen, when try to go and deliver a project, we always go and try to make a lot of estimation, okay? The question is, what is estimation? Estimation is like, you want to go, if I go and tell you I want to build a house, okay? You're not going to go and say, all right, have all the money you want in the world. You're going to go and say, all right, how much is it going to cost me to go and deliver and build that specific house? So what will happen is, we will need to go and make some estimation for you to tell you, okay, you need to pay me, let's say $1 million, $2 million, whatever that costs. I'm going to say you need to pay that specific amount of money to go and build and get that house. So estimation is really, we forecast how long is a project going to take me and how much is it going to take me for me to deliver to the client what he would like me to go and deliver. It's really about balancing the expectation of stakeholders and the need for control. Managers or someone who owns a house or someone who wants you to build a house, they're going to come and say, well, I want to know how much it's going to cost me. I want to know when it's going to be, because they can have control, they can monitor the cost, they can monitor the schedule, and so on. So we try to go and all the time create an estimate of all of these costs to go and deliver a project and how long they're basically going to be taking. And to be able to do that, we rely on what we've done in terms of the work breakdown structure a lot of time, especially when we're creating a bottom-up estimates. We need a work breakdown structure to tell me how much each task is going to cost me and how long is it going to take me. That's how we create the estimate if we've already created the work breakdown structure. But we don't always estimate by getting all of this detailed work breakdown structure. Sometimes we estimate what we call a top-down estimate, where a manager could come and say, for example, this project I estimate is going to cost me $1 million because he uses expertise and he knows based on that. Sometimes we go and estimate based on bottom-up, where we create all the work breakdown structure, we create every work package in that structure, and then we go and say, all right, how much time and how much cost does each activity going to go and cost me to be able to go and make that estimation. So you have a high level top-down estimate and you have a more detailed bottom-up estimate, which estimate every single potential activity in that specific project. For each one of these estimating methods, whether it's a top-down or bottom-up, they all various methods for estimation, which I'll talk about very shortly. Now, estimating cost and estimating time is very important. Why? Because we can decide at any point of time what we need to do. If we are, for example, over budget, we can decide better what to do. If we are running behind schedule, we can decide, all right, what do we need to do to be able to come back and become ahead of schedule? The estimation helped me schedule work, help me schedule the budget, help me determine how long the project is going to take me, help me know how much things are going to go and cost me, help me to go after I estimate the cost. When I start working on a project, help me determine how well the project is progressing. Is it progressing well from a cost perspective, or am I over budget? Is it progressing time in terms of time, or am I over schedule? So you compare what you say. Let's say I say activity 1 needs to be finished by day 5. If I come now and in day 10 and I check, and activity 1 who was supposed to finish in day 5 is still not finished in day 10, I'll know straight away there's something wrong. I can compare what I've planned to the actual performance. We can create a schedule, then we can develop a cash flow needs. When do we need money and how much do we need at any point of time? We can determine how well the project is progressing. We can determine the time phase budget. For example, phase 1 might be initiation, phase 2 might be development, phase 3 might be testing. We can know each phase, how much it's going to cost me. We can create all of these baseline. We can compare how we're performing against that specific baseline. Now, ladies and gentlemen, we go and talk about factors that influence the quality of estimate. Estimates don't need to be 100% accurate, and they're not expected to always be 100% accurate. For example, if I'm telling you to estimate how much the project is going to be taking 6 years, how much it's going to cost me, it's going to be very, very hard for you to estimate because it's a very long planning horizon. It's very different to me telling you, could you estimate to me how much it's going to cost me to create this product in the next, throughout the next 2 months? Why? Because the technology wouldn't have changed in the next 2 months. You already know all of this information. So the longer the duration, the harder to estimate. The planning horizon, you know, if I'm planning for, you know, again, this 6 years, it's very, very different than if I'm planning for 2 months. The sort of people that I have in my team affect the quality of my estimates. You know, people who don't know or don't have enough experience may give you wrong estimates. If I have a project structure, an organization that relies on a functional structure. Do you remember functional structure, matrix structure, project structure? Do you remember that? Do you remember that, guys?
Yes, sir.
Okay, so if I'm talking about functional structure and say go and make an estimate, it could be very unreliable estimate. Why? Because the person is going to be working on his job as a priority, not on the project as a priority. We have also another thing that influences the quality of estimates. People, a lot of time, likes to pad estimates. So if you go and ask a tester, how long is this activity going to take you? If it takes him 4 days, he might take 6 days. So that affects the quality of estimates. The culture, there might be fear that if we're not going to get the cost estimates correctly or the schedule, people are going to go and you know, be very upset with us. So people may basically go and change the estimates because of the culture of the business. Other factors, for example, if the coronavirus goes and hit and we are trying to deliver a project, the estimates quality will be very, very poor and we won't be able to go and possibly finish the projects on time. So all of these things are things we need to go and take in mind and consider. So what do we do to be able to get proper estimates? Well, there are some guidelines that are recommended for you to go and do. One, if you're going to get someone to go and estimate a task, employ someone who's familiar with that task. For example, if I want someone to go and estimate how much is this garden project's going to be cost me, I can't go and employ a painter and say, estimate for me this garden, because the painter doesn't know anything about the garden. So you need to get people who are familiar with the job being asked. If you want development, tell the developer. If you want testing, tell the tester. You want to get accurate estimates? Use more than one person. Okay, so you go and think, for example, 3 developers estimating a activity is better than 1 person estimating it. Make your estimation based on normal conditions, based on efficient work, normal level of resources, not if we employ more people, just normal. How long is it going to take a person? Use consistent time units in estimating the task. So if you are estimating using days, you estimate all of your tasks using days. If you are estimating using hours, you estimate using hours. Treat each task as independent. For example, if I say I want to go and paint a house, and painting a house requires, first of all, rubbing the paint, and next we say painting. You don't say, all right, rubbing the paint is linked to painting. You say, no, I will estimate how much rubbing will take by itself and how much painting will take. If I want to go and test a development software, and I know there's a developer needs to do his work and then the tester needs to do his work, I don't say, well, development and testing are related, so I'm going to go and estimate them together. No, you say, let me estimate the developer by himself, estimate he will get the job done within time, and let me go and estimate the tester doing his job by himself. Don't make allowance for contingency. In other words, don't allow people to go and change and overestimate so that they're going to go and have extra time. And adding a risk assessment really is important because it helps us to go and avoid surprises. If we believe risk could actually occur in practice, we need to highlight them and highlight what sort of impact they will have in terms of our time, cost, and resources availability. Now, ladies and gentlemen, guys, someone just joined us now. Who just joined us now? Just for attendance, who just joined us now? Someone just joined now? Who just joined us now? I need to mark for attendance, guys. Okay, Jayans?
Yes, Jayant Reddy.
Okay, Jayans, what's your surname, my friend? Can you talk again? Jayant's
1190.
Jayant's ready. Okay, that's fine. Now I just want to record you, my friend. Stay with us, buddy. I'm going to make sure I record your attendance later. Thank you. Okay. So guys, I'm going to start talking about the top-down estimate and bottom-up estimate. Top-down, usually derived from someone who uses experience. I know about this thing, and as a result, I'm going to go and estimate, you know, how much things are going to actually go and cost me from my perspective. They're usually made up of top managers, and they have little knowledge of the processes that are usually used to be able to go and complete a job. So it's like a high level. It's like I go and say, all right, I'm the CEO. I'm going to go and tell you how much the project is going to cost you. I say, but you know, Mr. CEO, you don't know anything about this project. It doesn't matter. I'm the CEO. I should be able to go and create an estimate. Now, this happens a lot of times in businesses, and it's not something very good. It's not something that the project team actually likes, because it will affect them basically making appropriate estimation. So these things should be avoided at all costs to be able to avoid having incorrect and inappropriate estimates. Another thing is bottom-up estimates. And bottom-up estimates.
Sir, you have not marked my attendance. I just checked it.
My friend, I haven't marked attendance yet. I just noticed that there's a few people who joined now. So I haven't marked any attendance. I'll be monitoring attendance all the way throughout the day, but I haven't marked attendance yet. So don't worry about it. If by the end you don't find your attendance, please make sure you ask me. Okay, my friend?
Thank you, sir. Thank you, sir.
Thank you very much. Now, ladies and gentlemen, bottom-up estimates are the opposite. It's like, you know how we spoke last week about creating the WBS? We spoke about that. It's like you use all of these WBS. You go and look at every work package in that WBS. And you go and say, all right, every work package, how much is really the work package going to go and cost me? How much time is it going to take? And so on. So you go and you get all of this detailed information that you have available, and you use that information to be able to go and conduct your estimates. Now, ladies and gentlemen, I'm going to talk about when should we do each type of these estimates, because they're both very important and they both have time. So it's not, I'm not saying that you do one but you don't do the other. I'm saying we need to go and check which one is important and for which time, for what sort of purpose. So I'm going to go and mention here, we have high-level estimates. When are they useful? They're useful when we are trying to make a strategic decision. They're useful when we are having a lot of uncertainty. They're useful when we are making an internal project, small project that we don't, it's not worth it for us to go and actually make all of this planning. It's useful when we have a scope that is unstable. That's when such information will be useful, such sort of estimate, high level. Detailed estimates are important, however, when costs and time are very important. They're very important to get the right costs when we are having a fixed price contract where someone will come and say, you know, I will go and deliver this project to you, and I will deliver to you if you pay me $100,000. If you go and make the wrong estimate and there's a mistake, you will have to pay for it. Multiplex, one of the biggest construction company, made this mistake when they were building the Wembley Stadium. They estimated wrong. They lost a lot of money in their project. You make a micro detailed estimate when the customer wants details. They don't want something high level. They want all of those details to be available to them. Now, how should we make the estimation? The best way to make it is you come in and you allow someone to make a top-down estimate based on their experience. That's one. Then you tell people, this is the project. You give them all the details and you say, I want you to go and create for me a work breakdown structure for that specific project. Just the same as what we have done last week. Then you use that work breakdown structure to estimate every one of those activities. How much is it going to cost you? And how much you believe the time required per item. That will help you to get a bottom-up estimate. You use all the details of every task to create an estimate for the whole project. And that information that you've added will help you develop your schedule and develop the full budget. Then what you do, you come and compare the top-down against the bottom-up estimation. And if there are any differences, you discuss them and you agree on what you believe the correct estimate should really be. So when I talk about top-down approach, there are many methods, and I'm not going to talk about every one of them, but there's, for example, the ratio method. And the ratio method is, the consensus method, where maybe senior managers come and agree together that this project is going to cost $1 million based on their experience. Ratio method is more about, we might say, you know, I'm going to go and have a certain percentage of work at a specific cost, and you basically use that specific approach. So you go and say, for example, I want to go and create 60 user stories, and I say every user story will cost me $100. 60 user stories, they're going to cost me whatever amount, 60 times 100 or 60 times 10. So if I say each user story will cost me 100, 60 user stories times 100, you basically calculate how much that specific user stories, all of them, are going to cost you. Apportion method is based on percentages. You might say the project is 100%, the project is $1 million, 40% of that project is development. So guys, if the project is going to be $1 million and 40% of that project is development, how much is it going to cost me, or how much is the budget for development? Anyone?
0.4 million.
It's $1 million for the whole project. 40% of that cost is development. So how much is development cost?
0.4 million.
Yeah, so $400,000. That's the apportion. Yeah. Function point method is you go and look at the project and you say how many functions is that in each project, and you estimate how difficult each function, and you use that to be able to estimate how much it's going to cost you and how long it's going to take. The learning curve method is one where it says if we are going to be doing repetitive tasks, we know that the first time we do this task, it might cost me $100 and it might take me 2 days, but the next time I'm going to do it, it might cost me $80 and take me only 1 day. So you start incorporating the learning curve to estimate high level how much a project is going to be costing. Now, ladies and gentlemen, is Navneet Kaur Shima here? I'm going to call some name. Shima Navneet Kaur, Akram Muhammad Ramzan, Nikki Shrestha, Bishal Rawood, and Sukhbir. Any of those people are here?
Yeah, Nikki Shrestha.
Nikki Shrestha is here. Okay, anyone else?
Yes, sir. Sukhbir is also here.
Okay, anyone else? Okay. Guys, it's very important you stay with me, especially from now on, because I'm having a lot of important calculations and I really don't want you to miss any of it, because it will affect all the future learning. All of these subjects and topics are interrelated, so please make sure you attend every lecture from now on and tutorial. Let's continue, guys. So I'm going to show you the example of the apportion method. The total project cost is $500,000. It is divided 20,000 design, 30% program, 40% testing, 5% documenting, and 5% producing. 20% of the 500,000 is 100,000, 30% is 150, 40% is 200,000, and so on. For design, which is only 20%, there's activity D1 and activity D2. Each of them will cost 10%, so each of them will cost $50,000. For activity program, there's 3 activities, P1, P2, and P3. First one will be 20% of the budget, second one is 5, third one is 5. So that's 100,000, 25,000, and 25,000. So that's, ladies and gentlemen, in terms of how you use the apportion method. And I can tell you, there are some calculations you need to be doing today as part of your tutorial. So please make sure you know how to do them, because they will be in your midterm exam. Sorry, in your quiz 1.
Yes, sir. Okay.
Sukhbir,
Yes, sir.
focus. Go.
Okay, sir.
Now the second one is a function point. And a function point, the way that it works, we're going to have all of these functions that we are going to be producing in the actual software. We're going to have 15 inputs, 5 outputs, 10 inquiries, 30 files, and 20 interfaces. We look at how complex each one of these are. 15, low complexity, 2. 15 times 2 is 30 function points. 5, complexity is average, so that's a 6. 6 times 5, 30. Inquiry, 10 times average, 4, 40. This is a high complexity, 30 times 12, 360. That will help you to calculate your function points required for the project. And based on that, it will help you to go and know how much you charge per function point and how much it's going to go and take you to go and create all of these function points in a project. So you will know the duration to go and create these function points. I'm going to show you something else now. I'll show you a quote for you creating a certain application. Just trying to find. All right, let me just open the email. I'll show you via email because it came through via email. So, okay. Look here, I'm going to show you 2. Okay, there's this one, and there is. Okay. So guys, have a look at this screen. That's a project that one person basically gave a quote. It's an application that is going to be delivered for a charity. You know, the way that people looked at it is they look at what are we trying to go and deliver? You know, user interface, we're going to go and create it, the super user, the application, the coordinator, there's all of these people. You go, there's a user. You go and see that I want to be able to create a login so that volunteers, coordinators, and shift leaders can use the system. Okay, great. The guy went and said, this request is going to take me 5 days to complete. I am charging $50 per person for this task. So this task is going to cost me $250 in terms of budget. I'm going to quote it this way. I want to go and have able to activate and deactivate volunteers. This will take me 3 days to go and set up. I want to charge $150 for it. Every single requirement that that company has been asked for, they wrote it in that document and they calculated how much the whole project is going to go and cost them. They are charging $12,750 US to go and deliver that project. They're going to make a mobile application on Android and iOS, and they are going to make also a web interface so that we can actually go and use it on the internet. That's one way of estimation in practice that someone just did. That's another one. If you go and think about, let me try to find that. Okay, can you see the screen?
Yes, sir.
Can you guys see the screen? This is another company. You know, they're giving all of these things, you know, what we do, you know, our revenue, our employees, and they're giving all of this information. And they go down and they're not giving detailed information, but what they're saying is saying, all right, we are going to deliver. Can I just get you? Look here. We're going to go and create this CMS functionality for you. We're going to go and create a super user. We're going to be able to go and coordinator. We're going to be able to do reporting. We're going to be able to go and, you know, this is how much it's going to go and cost us. You know, that's 5 weeks, that's 6.5 weeks. It's like for every task, it's saying how long it's going to go and take them. And they're going to say, that's how much we're going to charge you for design. That's how we're going to charge you for app. So there's all of this information leading all the way to their final price of how much it's going to go and cost them. This guy is charging, you know, $500 per man day to go and deliver it. There's obviously hosting and other stuff, but I'm just showing you practical ways that companies will be able to go and create real IT estimations for going and actually quoting all of these specific jobs. Now, I'm going to stop for a second and ask, does anybody have any questions, my friends? Anyone?
All good,
all good? All right. Let's continue. So, advantages of making a top-down estimate is the overall project budget can be set and controlled very accurately, especially if senior management would like to go and have very high control on specific budgets. So basically, the control will be available for senior management. And because we're not really making detailed planning, we don't need all of this time to be able to go and make the early estimation. So there's no need for me to go and spend a lot of time in all of this upfront planning. On the other hand, there are disadvantages of working in this specific manner. One, if you go and tell a project team to go and work based on a budget that they have not developed, it's going to be very hard for them to go and accept your budget. They're going to say, it is your budget. We haven't estimated it. We don't have confidence that your budget is correct. And because of that, we are not really willing to go and accept your budget that you went and you gave us. It leads to low level competition for a larger share of the budget, especially if, you know, there's competition and there's a culture of competition in the business. So people from various teams, from various projects will start competing against each other. Because it's high level, guys, someone is just having a background. Sayed. Okay. There's no details available because it's simply a high level estimation and there's no contingency added. So what if something was to go wrong? What if there was an issue? What if there was a coronavirus? What if there's a problem? There's no contingency added to that sort of example. So it's an issue because it's a high level, it's have advantages and have its disadvantages. On the other hand, there's a bottom-up estimation. Really, we go and try to find in detail what's the project time, what's the project cost, and so on. The way we estimate bottom-up, sometimes, let's say we are talking about a repair job. A company might have a very standard format for every repair job. So you use that template and say, okay, estimate each one of these, estimate the time based on this template, and estimate the cost. Every job is identical. Parametric procedures apply to specific tasks. It could be something like I need to go and create 20 user stories. Every user story requires 4 employees. So I know I need 80 employees days. And every employee, I'm paying them $100. So I need $8,000. So you go and say, I have 80 stories or whatever, 40 stories. For every story, we have 2 employees. So 40 times 2, that's 80 hours of work. Multiply $100 per hour. That's $8,000 I need for that specific job or for these 40 user stories that I would like to go and create. A third method is what we call range of estimates. We use a PERT method. When we're going to go and estimate a task, we estimate what's the optimistic time for me to finish this job, what's the most likely time I need to finish this job, and what's a pessimistic time for me to go and finish this job. Using a formula, I use the pessimistic, the normal time, and the optimistic time, and I use them combined to be able to go and know how much a project is really going to go and be to be able to be completed. Finally, there's a combination. I might be using template method with, let's say a PERT method or any other things. That's not a problem. Some people go and do that. I want you to look at this example. This example is giving you the low estimate, which is the optimistic estimate, the average estimate, and the high estimate, or an otherwise pessimistic estimate. The way that they calculate it is they say 1 multiply low estimate plus 4 times multiply average estimate plus 1 multiply high estimate or pessimistic estimate divided by 6. So if you were to look at, let's say, the approval, 1 times low estimate of 1 times 1 is 1, plus 4 times the average, 4 times 1, 4, so 4 plus 1 is 5, plus 1 time pessimistic, so 1 times 3, so 5 plus 3, that's 8. 8 divided by 6, that tells you this job is going to take me 2 days to be able to go and complete. My friends, does that make sense? BJ?
Yes, sir.
You understand how I've done that? VJ?
Can you repeat one more time, please?
Absolutely.
I'm here, sir.
Focus, guys. Focus how you do this, okay? So the way that you calculate it is 1 multiply low estimate plus 4 times multiply average estimate plus 1 time multiply high estimate. So 1 times 1 is 1 plus 4 times 1 is 4 plus 3 times 1 is 1. So 1 plus 4 plus 3 is 8 divided by 6. That will be 1 point something. You calculate based on full days, so that will be 2 days for you to go and complete the job.
Sir?
Yes.
Hello?
Yes.
Is there any formula to calculate this thing?
Yeah, the formula is 1A plus 4 times B plus C divided by 6. It's called the PERT method. And really 1A equal 1 times optimistic time plus 4B, which is plus 4 multiply most likely, plus 1C, which is plus 1 multiply pessimistic, divided by 6.
All right, sir. Thank you.
Does that make sense?
Sir, can you show us the
Yes.
formula?
I'm gonna put it for you. So it's 1 multiply optimistic plus, I'm gonna just type it so that everybody will be able to see it, plus 4 multiply most likely plus 1 multiply pessimistic divided by 6. I've sent it to all of you. In this example, the optimistic is the low estimate days, the most likely is the average estimate days, and the pessimistic is the high estimate days. Does that make sense?
Yes, sir.
So 1 times 1 plus 4 times 1 plus 1 times 3 divided by 6. How did you get 6? 1 plus 4 plus 1 equals 6. That's why you divided by 6. Does that make sense, guys?
Yes, sir.
Yes, sir.
Let's continue. Now, the advantages of getting a bottom-up estimate, because the project team did it themselves, they would be happy to accept it. They will be happy to go and catch, potentially, they will be able to catch any expense that is unusual, because why? They plan the details. However, people, disadvantage, people often try to say, overestate how much a budget or a task is going to take. They create what is known as padding. And when they do padding, management comes back and say, this is too much, I'm going to cut it down. So you have a bit of fighting happening between people. Now, the level of details is very important, guys. You don't want to have too much details and you don't have no details. You're going to have appropriate details. Why? So much details is going to go and become very focused on every department doing its job. It's going to go and become unproductive paperwork. And if you're going to spend so much time planning, the opportunity may be lost because you spent so much planning, whether you want to go and implement that opportunity. Insufficient details, however, is costly because you may not have clarity on all the tasks that are required. You might have a lot of waste of effort because when things go and start having an issue, because you haven't thought about all of those details, you might need to waste a lot of effort and time to be able to find a solution for all of these problems. Now, when we talk about project costs, there are so many costs. There are direct costs, direct overhead costs, and general and administrative overhead costs. We will be talking about costs and especially making a lot of cost calculations, I think in week 6 or week 7, but there's going to be calculations you guys will need to do. But in simple terms, direct cost is like I tell you, okay, I want to develop this user story. You say, all right, to develop it, I need to go and have this person working for me, so you know you need that labor. I need to go and use this specific testing computer, so you know you need that equipment. That's going to be a cost directly associated with those specific projects and with those work packages that we need to do in terms of all of these projects. Direct overhead costs. Costs incurred that can be tied to project deliverables or work packages. For example, a project team might be working in an office, and without that office, they cannot go and get the job done. So if that's the case, that's going to be the rent that you can link to the actual project. If we talk, for example, about the project manager might not be working himself on any work package, but he's managing the whole project. His salary can be linked and tied to the project, although not necessarily to a particular work package. General and administrative overhead costs indirectly linked to a specific package that are apportioned to the project. For example, we might think we have in this business a human resource department, and that human resource department is the one who helps us to go and recruit all of those people to this team, while the HR department is not working on the project. Without them recruiting those people I need for my project would not have been completed. Now, when we talk about cost, we talk about different type of cost. We talk about scheduled cost. What does that mean? When I go and plan my project, I might say, I'm going to go and create a scheduled budget. I believe in day 1, I'm going to be needing, in this example, maybe $500. That's what I scheduled. That's what I've planned I need. Actual cost is how much the project cost me at that point of time. So yes, I might have scheduled that I will need to spend $500 by week 1, but my actual cost is only $100. So I basically saved money. Now, we might have scheduled that we need to spend $500 in week 1, but because we want to make sure we don't run over budget, the project manager or the CEO might have committed $800 for us. We don't need to spend 800, we can only spend 500, but in case anything was to go wrong, there's extra costs committed for that project and the event we are going to be needing it. So scheduled is what we scheduled to really spend at that point of time. Actual is how much did we actually spend, and committed is how much have been committed in terms of fund for the project by this specific point of time. Ladies and gentlemen, do you have any questions? Okay, so I'll take that as no, and I'll continue. Now, Bishal Rawoot, Muhammad Ramzan Akram, and Shima Navneet Kaur. Any of you are here?
Yes, sir.
Which one?
Muhammad Ramzan Akram.
Muhammad Ramzan Akram?
Yes, sir.
Shima Navneet Kaur and Bishal Rawoot. Are you here? Does anybody of you know these people? Shima Navneet Kaur and Bishal Rawoot. If you know them, please tell them to come and join the class now, because what I'm covering next is very, very, very important, especially for the calculations from now and going forward. This is the primary calculations I am going to be teaching you today. It will be in your final exam and it will be in your quiz. Okay? Because I'm going to start talking about that now. Ladies and gentlemen, you know how we created a work breakdown structure? We created a work breakdown structure last time. I'm gonna go and try to go to Google and show you some stuff. Okay, so okay, network diagram. Okay, project management. No, I just want to have an image. Okay, guys. Guys, have a look at my screen. Can you see this small screen? Can you guys see? Salman, can you see my friend? Salman Khan? Okay, Salman is obviously not focused. Alina?
Yes, sir.
Okay, can you see the screen, the white screen?
Yes, I can.
Okay, perfect. Now, I want to go and run this by you guys. Guys, you know how last week we spoke about a work breakdown structure? Work breakdown structure is as simple as all the activities we need to go and complete for the project. Now, knowing all the activities is great, but they're not going to help us much if we don't know when every activity is going to start and when every activity is going to finish. It won't help us if we're not going to know which come first, which come next, and so on. It's not going to help us if we don't know how much each activity is going to take me. So if you look at this example, this diagram here is what you guys exactly need to draw very, very shortly. You see, instead of saying all of this work breakdown structure, put the activities on a Word document and put them as level 1, level 2, and level 3, here you're saying what's going to happen first, what's going to happen next. So in this example, activity A will happen first. Then there's activity B and C. Both of them will come after A, which comes before it. So B and C. Then there's activity D, which comes after B. That's here. Then there's activity E, which comes after C. That's here. And there's activity F, which comes after D and E. And that's here. This is an example of bringing work breakdown structure into a network diagram where we start saying, all right, these activities on the work breakdown structure, when are they going to start? When are they going to end? And what's the duration for each one of those activities? So ladies and gentlemen, the network diagram calculation is really what I need to teach you today that is really, really important. A project network is really a flow chart, which is exactly as the one that I just showed you. It uses the work breakdown structure and it creates a graphical representation of the activities order. What comes first and what comes next. Because we know what comes first and what comes next, and we know the relationship between the activities, we know the duration required for each activities, we know when each activity needs to be done, it will give me a basis. I can use it to schedule my labor, when do I need them, schedule my equipment, when do I need it. It's going to help me to enhance communication among project participants, because if, for example, I have task 2 that is reliant on task 1 and they're done by different people, task 2 person will be able to speak to the person doing task 1. Make regular communication to try to ensure the job is done when it's supposed to go and be done. We become having a good estimate for the duration of our project. Because we know when each activity needs to be done, we'll be able to know how much money we need at each stage or at each activity or even at each day of my project, because we basically have calculated how long each activity is going to take, who's going to do it, and how much they get paid per day. We identify the activities that are critical. We call it the critical path, and we'll make the calculations together a bit later. The critical path is where no activities on that path, which is on that road, no activity can be delayed at all. And I'll show you an example very soon about that. We highlight activities that are not critical, which mean there are some activities on the project that can be delayed without having any negative impact on the project. And we're basically using all of this network diagram. It will enable us to go as project managers to ensure we stay on plan, we do deliver things on time, and we monitor according to the initial planning that we've went and we have created. Now, ladies and gentlemen, as you know, I usually give you a break towards halfway in my lecture. We are now halfway towards the middle of the lecture. So what I'm going to do is I'm going to give you 10 minutes break, and we'll resume back immediately at 4:11. So I'm going to give you a break, guys. Please come back at 4:11. Enjoy your break, eat, do whatever you would like, and let's continue very shortly. All right, so thank you very much, guys, for coming back. I want to communicate that what I'm covering now is very, very important. Do not miss it. Make sure you are here to learn about it. So don't go anywhere. Don't not focus. Please stay with me. Now, if you go and look here, there's all of these work packages: specification, documentation, prototype, final prototype, testing, software preliminary, and so on. Now, when you go and create a work breakdown structure, you will get all of these work packages, and that's a great foundation. However, you won't know when something can start and when something can end. That's what a network diagram will tell you. So here, we have 2 work packages which were combined to be activity A, and to start, it's going to take 2 days. And after that, there's prototype and final prototype, which going to go and come as B and D. And there's preliminary software, which is going to come straight at the same time as prototype. And then finally, after the final prototype, we'll go and create the final software. And after the final software, will go and do all the testing. So here you can see we moved from what are the work packages to something very specific that says when each work package needs to go and be completed. What comes first and what comes after. So if I go and look here, there are so many various terminologies to go and think about. There's one, activity, or a work package if you want to. An element of the project that requires time. So I could say I want to go and write a code. It's going to go and take time. I'm going to test user story A. That's something that is going to take time. Second thing, merge activities. An activity that has two or more preceding activities on which it depends. So A and B, they're both merging into activity D. Okay, Salman. Salman, please focus. You've been for a while not focusing. So
Yes, sir. Yes, sir. Yes,
okay?
sir. Yeah.
Now, so merge activity, an activity that has two or more preceding activities which depends on it. So D depends on both A and B at the same time. D depends on A and C at the same time. Parallel activities are activities that can occur independently if desired, but not at the same time. So if you want, I have activity A and B. They could start at the same time, but they don't necessarily have to start at the same time. When I talk about a path, path is like a road. There's a road between A and D. There's a road between B and D. And there's a road between B and C. So in this example, there are three different roads for us to go and think about. There's also what we call a critical path. You see, when I talk about a path, AD, BD, and BC, every one of those activities consume time. The critical path is the path that will take the maximum amount of time. So if AD is 10 days, BD is 7 days, and BC is 6 days, AD is the critical path. Why? Because if you delay BD pass, if you delay any activities on that path, it's going to go and delay how long the project is going to actually take. So that's a critical path. Event or milestone is a point in time when an activity is started or is completed. It does not consume time. I spoke last week and gave you the examples. I said, you know, call the accountant, set up the company, speak to whatever, and then at the end you say, company setup complete. That's a milestone. It's indicating either something has started or something has actually ended. A burst activity is an activity that has more than one activity immediately following it. Okay? More than one dependency. So it's not merging, it's bursting. That's how we burst. So it is really opening the hands. So you can see, for example, activity B is opening its hand, and the activities after it is D and C. In contrast, activity D is merging. A and B are merging into D, but B have a burst activity that has two activities after it, which is B, D, and C. So this is here, sorry, what I call a burst activity. Why? Because it is open and there's two activities bursting from B to get D and C done. Does that make sense? Any questions, my friends? Zika, any question?
No, sir. So totally fine.
Perfect. All right. So let's continue. Now, let's talk about a network diagram. Now, to set up a network diagram, there's some basic rules we need to go and follow. First of all, network diagrams flow from left to right. So you start drawing it from left to right. An activity cannot begin until all preceding activities are complete. So if I have activity B is a merge activity which have A and C before it, B cannot start until A and C have completed. So that's what I call in terms of merging activities. Arrows indicate a precedence and flow and can cross over each other. And I'll show you, for example, I'll show you a bit later the example of arrows crossing over each other. But in simple, simply, the arrows tells me this activity comes first, and the arrow from A to B means after A is finished, we can start activity B. That's what the arrow actually means. Each activity must have a unique number that is greater than the number that is before it, for the activity before it. Looping is not allowed. In other words, I can't do activity A, B, and C, and then go back and do more work on activity A, which is finished. Activity A, B, C, you keep on moving. Conditional statements are not allowed. For example, you can't say, well, if B is going to take more than 5 days, then I'm going to do activity D first. No, you can't. There's no optional. You go and follow the network. There's no conditions that you can impose on that network. Finally, use common start and stop nodes. Okay, common with, especially at the beginning, you can put that common node and everything starts from it, every other activity, and then when you reach at the end, you'll create a common node at the end so that all the activities will match to it. Now, sometimes we use that because it makes it easier for us to calculate, and I'll show you that. But this is some rules really that are relevant to creating a network diagram. Now, let's look here. You can see activity A, there's nothing before it. Activity B cannot start until activity A is completed. And activity C cannot start until activity B is completed. I'm going to ask Anushka.
Yes.
Is activity C a burst activity or a merge activity? Is it merging into something or is it bursting into something?
I think it's merging.
No, it's not merging. X is not merging, means it's merging. X is merging into two other activities. There's no merge here. Activity X is opening its hands and it's bursting out to two other activities. So from activity X, there's two activities coming after it, being activity Y and activity Z. Can you see how the hands are open? Can you see that? Can you see my mouse?
Yeah, I can.
It's open, okay? So two activities are bursting. So from X, we're getting Y and we're getting Z. Does that make sense?
Yeah.
Can Y and Z start at the same time?
No.
Yes, they can, because they are in parallel. Nothing's stopping them from starting at the same time, but they don't need to start at the same time. Y and Z have activity X before it. Y and Z can become at the same time and start, but they don't necessarily have to start at the same time. If we choose to delay one of them, we can do that. There's no problem. X is a burst activity and two activities are bursting from it. Do you understand?
Yeah.
Okay, now let's look here. I'm going to ask you this other question. Is it a merge activity or a burst activity? Are the activities merging into M, or there are no activities merging into M?
It's merging.
M is a merge activity. I have three activities before it. Can they start at the same time?
Yeah.
They are parallel. Do they need to start at the same time?
No.
Can X and Y start at the same time?
Not necessarily.
But they can, yes?
Yeah.
Okay, is that a merge or burst activity?
Merge.
Merge. What about Y? Is it a burst or a merge activity? It's a burst because there's two activities going from it. Does that make sense?
Yes, sir.
Do you understand? If anyone is not clear, you better ask. You know, all the questions are good questions. You just need to ask me. Okay. Wadia Very. What's that? Jorvir, was that message intended to me or to someone else? I'll assume it's for someone else. Okay. Now, I'm going to go and continue, guys. So I'm going to give you this network diagram. Alina. Alina?
Yes, sir.
Which activity, look in front of you, which activity must go first?
Hello, sir?
Yeah, which activity must go first? Have a look.
First,
Which
B, C, D?
No. Which activity have nothing before it?
The application approval.
So activity A has
yes.
nothing before it.
Yep. Yes, sir.
Okay. Thank you very much.
Welcome, sir.
Bidur. Bidur?
Yes, sir.
After activity A,
Yes, yeah.
after activity A, which activities I can do? Which activities?
Start, sir.
What's
It's
that?
like
You're cutting off, my friend. I can't hear you.
B and C. Sorry for that, sir. B and C.
I think B, C, and D can be started
B,
parallelly.
C, and D, correct. B, C, and D, they can come straight
Yes,
after A.
Yeah, exactly.
Make sense?
Yes, sir.
Then after B and C, what comes after B and C?
E.
E. Okay, that's correct. What and then after B, C, and D, which is these ones, we have F. And after F, we have G.
G.
And after E and G, we have H. Now I'm going to show you. Have a look at the diagram. Before I move next, I want you to have a look and make sure you understand how this diagram was drawn. So take a minute to contemplate it and ask me if you're not sure. Does everybody understand how this came through?
Yes, sir.
Okay, anybody
Yes,
know
totally
you
fine.
guys?
So what is that thing, that legend, ESID,
That's what I'm doing next for you.
Okay.
So description is a description of the activity. The ID is the activity ID. We gave it an ID A, B, C, D, and so on. Dur is the duration of the activity. That's 1, 5, 15, 10. That's entered here. ES, EF, LS, LF, SL. These are things I'm going to be calculating now.
Okay, sir.
Make sense?
Yeah, thank you.
You're very welcome. Anyone else got?
Sir, are there any levels like level 1 is A and like suppose level 2 is B, C, and D?
It's
so are
not
there any
levels.
levels?
It's not levels. It's just more about when each activity. You know how we create? Were you here last week?
Yes.
Okay. You know how we created last week a work breakdown structure?
Yes, sir.
So what this one is doing is more about, we are taking this work record structure and we are saying which of those work packages in the structure will come first, which will come next, and which will come after. So you're putting them in order. That's all what's happening here.
But sir, according to the table, E comes first then F, but why it's like in the graph, in the network diagram, we can it's different.
Okay, which one are you talking about? E?
Yeah, E and F.
Because you need
in
to
the diagram.
you need to go and see. Okay, first of all, F comes after BCD. So this is the one level straight after BC and D. Okay, but if you go and think about activity E, so E is B, it's going to be in C. The way why they've done it this way is because you see how there's activity H?
Yes.
Activity H is coming immediately after E and G. That's why they put it this way.
Okay, okay, all right. Sir.
However, even if I was to bring E and put it next to F, you'll get the same answer.
Okay.
Does that make sense? Because the arrow, the relationship don't change. So if you bring the box a bit back or a bit to the front, it will make no difference for the calculations. But for the visual things, they put it close because those two activities are required for the last activity to be completed.
All right, sir.
Make sense?
Yes, sir.
All right. Now, that's where you need to go and start thinking. Early start is how early can an activity start. Early finish is how early can an activity finish. Expected time is how soon can we expect the project to be completed. How early can we complete the project, in simple words. When we're going forward from left to right, we calculate those calculations. And you will see many examples today, but we do all of these calculations. When we get to the end of the network diagram and we try to calculate things backward, we calculate latest start, latest finish, slack. Latest start is the latest time an activity can start. Latest finish is the latest time an activity can finish. Slack is how long an activity can be delayed without delaying the project. And critical path is which activities on the diagram cannot be delayed, because if they get delayed, they will delay the project. Now, these are all things that are new, you know nothing about, and I'm going to try to explain to you now. Now, there's a slack, the amount of time an activity can be delayed and not delay the project. There's a free slack, which is how long an activity can be delayed without delaying the early start of the activity immediately after it. Okay, so there's two types of slack. Slack, total slack is if I delay one activity, the end project will take longer. And a free slack is if I delay one activity, it will delay the activity after it. Not necessarily the overall project, but the activity immediately after it. Sometimes we say a network diagram is sensitive, which means that you don't have a lot of slack available in the diagram. You might have one path to do the work, which might take 20 days, and another path which will take 19 days. Because there's very short difference between 19 days and 20 days, you say this path, which is 20 days, is very sensitive, because if we delay that specific path by even a day, it will basically become a critical path. So you need to think about, you know, how much slack or how much, time you can delay activities. The more slack you have, the more you can delay activities, the more you'll be more comfortable into managing the project in being able to go and deliver it on time. The more there's more than one path, and those paths, one of them, let's say 120 days, and one of them is 19 days, what it means is if you delay one pass for 1 day, you then have 2 critical paths. And that makes it much more difficult for you to go and manage a project. We'll see examples of this, but I'm going to start showing you the calculations. This is very, very important to follow. This is what you will need to be doing in your tutorial today. This is what's going to come in your final exam. And this is part of what's going to come in your quiz. So if anybody is not focused, that's the time to focus. 1. We add activity time along each pass in the network to the duration, which will give us early finish. So if I do early start plus a duration, I will get an early finish. So early start plus duration. Can you guys following? Are you following?
Yes, sir.
Yes.
Yes, sir.
Give me the early finish time. Then we carry the early finish time to the next activity, and it becomes early start time unless rule 1 below. So this is early finish from activity A. Because there's 3 activities after it, I, F, and C, it becomes early start for I, F, and C. So the early finish becomes early start. Does that make sense?
Yes, sir.
Repeat this point, please.
Unless rule 1. Rule 1 says, unless the next activity is a merge activity, it's merging. If it's a merge activity, then we use the largest early finish time as the early start for the next activity. So, activity J is a merge activity. Before activity J, there's early finish for activity E, early finish for activity H, and early finish for activity G. To know what the early start is going to be for activity J, we need to see which early finish is largest. Is it the one for G, the one for H, or the one for E? The largest out of those 3 will become the early start for the next activity. Does that make sense? Does that make sense, guys?
Yes.
Okay.
Excuse me,
so
sir?
we're using the formula in G, H, and E, is it?
What's that?
So how are we calculating that?
G, H, and E
Yeah.
are all merging into J. So J
Yes.
is the merge activity.
Yes.
To know what's the early start for J, you need to choose the largest early finish between all the activities merging. So you need to see, is the early finish of G bigger than H and bigger than E? If yes, then you will use the largest early finish to become the early start for J.
Okay.
Does that make sense?
Yes.
But here in this case is the H, right? The
You don't know
early-
yet. Let me show you. We haven't done it yet.
All right, no worries.
So now, 0 plus 12 equal how much? So 0 plus 12 equal how much, guys?
12.
12. So the early finish, early start plus duration, give me early finish. Does that make sense?
Yes.
Okay, when can activity B start?
0.
Okay, 0. How many days does it require?
9.
9.
What's the early finish?
9.
9.
Does that make sense so far?
Yes.
Okay, now, I want to look at activity A. The early finish is 12. What's the early start for I?
12.
12. What about for F?
12.
What about for C?
12.
12. 12 plus 15.
17.
27.
27.
12 plus 10.
22.
22.
12 plus 10.
22.
Perfect. Now let's look at D. When can D start?
9.
9.
9.
When can E start?
9.
So 9 plus 10.
19.
Okay. 9 plus 24.
35.
33.
33. Now let's look at G. When can G start?
22.
22.
22. Correct. From here to here. 22 plus 35.
57.
57.
57. What about H? When can H start?
19.
19.
Okay. 19 plus 40.
59.
59.
Now let me ask you. J is a merge activity.
Yep.
Which one is bigger? The
59.
early finish of
59.
E, H, or G?
H.
H.
So that's 59. 59 plus 4.
63.
63. Perfect. Now let me ask you, is K a merge activity?
Yeah.
Yep.
Yes.
Okay.
Yes.
What's merging into K?
I.
J, F, and I.
I, F, and J. Which one is the biggest?
J.
27.
Yeah.
I.
J. J.
J. J is how many days?
63.
So 63 becomes
Starting off K.
69.
63 and 6 becomes 69. Does that make sense?
Yep.
Yes, sir.
That's a forward pass calculation. Well done.
Thank you, sir.
Now we need to go backward.
I just have one question.
Tell me.
So, I mean, how is this like the logic? So there is 33, 59, and 57 for G, H, and E. So why can't it be the E? I mean, 33 days. Is
I'll
it
tell you
listed?
why. Because you need to calculate the longest duration of the project. If you use G, for example, it's 57 days, which means the project will finish earlier. But in reality, it can't finish earlier because there's an activity that will take longer. So even though G might finish first, H cannot start because it will require more time.
Okay.
So because it's going to require more time, that means J cannot start on day 57 because he's still waiting for activity H.
Oh, yeah.
Make sense?
Yeah, so we can't start J without finishing all those
You
three.
can't finish it because it's a merge activity.
Yeah.
You understand?
Yes. Yes.
Okay. You're going to get a lot of practice of this today, so you better understand. Now, when we want to move backward, we start with these rules. First of all, the latest finish minus duration give me my latest start. So currently, we have the early finish is 69. Can you see that?
Yeah.
This becomes latest finished. So this becomes 69. So the early finish becomes the latest finish. The 69 becomes the latest finish. The latest finish minus duration give me my latest start. So 69 minus 6 gives me what?
63.
63. Then the latest start move to the activity before it unless rule 2. So where does 63 go?
I, F, and J.
Correct. It will go to I. 63 minus 15.
38. 48.
Okay, so let's just put that. 63 minus 15 is 48. 63 minus 10?
53.
53. And 63, you see J, minus 4?
59.
59.
59.
Does that make sense?
Yep.
Now, where does 59 go?
G, H, and E.
Okay, G. 59 minus 35 is 24. H. 59 minus 40.
19.
Equal?
19.
19. Now let me ask you. We have a G which is a latest start of 24. Okay? What's the latest finish for C?
24.
That's 24, correct? But let's just go first. So you see here how we have J is 59. We move to 59 from latest finish. Sorry, from latest start becomes latest finish. So 59 minus 24 is 35. Then we move 24 minus 10 equal 14. Then let me ask you, what goes in D?
19.
19. 19 minus 10?
9.
9. So 19 minus 10 equal 9. Now let's go at activity A, okay? Because that's important. Now, unless the activity before it is a burst activity. So A, there's 3 activities bursting from it. Because it's a burst activity, we will use the smallest latest finish time, okay? So let's go. There's a latest finish of 48. There's a latest finish of 53 and the latest finish of 14. Which one is the smallest?
14.
14, 53, or 48?
14.
14. Okay, so that's again a burst activity. There's 35 and 9. Which one do we go? Which one is the smallest?
9.
Okay, so 9 minus 9 equal?
0.
0. And here we set 14 minus 12?
2.
2. So that's how you calculate the backward pass calculations, which you will need to go and apply for me very shortly in the tutorial. Does that make sense?
Yep.
Are we clear?
Yeah.
Now, the final thing we need to calculate is what we call the slack. Now, we know the longest duration for the project is 69 days. That's how long the project is going to take. But to calculate the slack, it is either you do latest start minus early start or latest finish minus early finish. So, latest start of 0 minus early start of 0 equal how much?
0.
So that's a 0 slack. 9 minus 9?
0.
19 minus 19?
0.
59 minus 59?
0.
63 minus 63?
0.
These are all my critical paths. 0 means I cannot delay any of these activities, and that's why they are all circled in red. Does that make sense? Does that make sense?
Yes, sir.
Now, 2 minus 0?
2.
2. 14 minus 12?
2.
53 minus 12?
41.
Now you see how all of these other activities have slack. Means you can delay all of these. I can delay I for 36 days. I can delay A for 2 days. I can delay F for 41 days. You see, some activities have a lot of slack. You can delay them without delaying the project. And some activities have no slack. They are on a critical path. They cannot be delayed. Does that make sense?
Yes.
That's the calculations. That is the basis for a lot of the chapters going forward. You need to understand that today and apply it today and apply it in your quiz next week.
So I have a question.
Tell me.
Yeah, for the slack, we have to calculate for each node. We have to calculate the slack, or
each node.
Okay.
Each node needs to be done, my friend. Make sense?
Yep, sure.
All right. Now, you always create the baseline for your project. That tells you when I plan the project, I plan how long it's going to take me. But if you compare this example, you notice that activity F was supposed to take 12 days. Look here. But in reality, it's now estimated to take 13 days. And it's estimated to start 1 day longer. Why? Because on a network diagram, when one activity on a critical path is delayed, the activity after it will be delayed, which is what happened in this example. This will be delayed. It will delay the other activity that is on a critical path. That's why you must know the critical path and you must manage the critical path. Now, ladies and gentlemen, not all activities have a finish to start relationship. You know, in these examples that I'm giving you here, you can see the arrow from the end to the start. That means finish. We need to finish this activity before the next one starts. This is beginning. Finish to start. Finish to start. Finish to start. Not every project activity is a finish to start activity. Some are start to start, which means activity B cannot start until activity A starts. Some is finish to finish, which means activity B cannot finish until activity A finishes. Some have start to finish, mean activity B cannot finish until activity A have already started. Okay, there's all of these various relationships. Some of them are rare, some of them occurs more often. There are also sometimes things we call lag. In other words, you might say activity B cannot start until 5 days after activity A has finished. For example, if I'm building a big construction company, I cannot pour concrete and go straight away tomorrow and start building again. You have to wait for a few days. That's why we say activity B cannot start until 5 days after activity A has finished. Finish to start plus 5 days. That's what we call lag that we go and incorporate as part of our calculations. In this example, activity Y cannot start. You see the start here? This is the beginning. This is the end. Until 19 days after activity X finishes. Activity Q cannot start until 5 days after activity P has actually started. This is the start of the project. Here, activity lay pipe cannot start until 3 days after trench mile has started, and activity refill cannot start until 3 days after activity lay pipe have actually started. This is another example. Activity testing cannot finish. You see how it's finished here. Cannot finish until 4 days after activity prototype has finished. Here, system documentation cannot finish. This is a finish unless 3 days after activity testing has started. So there's all of these relationships that you will create and you will usually put in your Microsoft project when you're working on more than one activity. Just so that you will know that not every activity is a finish to start. In your calculation, I won't be giving you many lags, if any, but I want you to understand that sometimes there are relationships and sometimes there could be delays from one activity to another activity. Now, ladies and gentlemen, in traditional project management, every activity gets done one after the other. In reality, nowadays, a lot of activities happen at the same time. Planning, you don't need to finish it so that you can start engineering. Engineering don't need to finish before we start engineering, design, development. Procurement doesn't have to wait until engineering design is finished. We can do things in parallel, and that's how things are being done nowadays in practice. Ladies and gentlemen, this is everything I would like to go and cover for you today in your lecture. Do you have any questions?
So can you go before 2 slides? Like there is something like combinational relationship. Yeah.
Yep. The combination here, you cannot debug. Okay, debug cannot finish until 4 days after coding has started.
Yes.
And debug cannot start until 2 days after coding has started. So there might be more than one relationship between activities.
Okay.
Does that make sense?
Yes, sir.
All right. Any other questions?
Thank you.
No worries. Guys, I want to remind you that for those who are here with me on the first time, I want to remind you that you're not a number in my classroom. You are someone who's very important, someone who I really truly go and care about, and I want to make sure I help you to reach your full potential. So I want you to go and ensure that if there's anything you don't understand, if there's any help you need, you always come and actually ask for your assistance, because without asking questions, I won't be able to go and help you. Today, for example, we are going to be doing a lot of calculations. I want you to only come to your specific tutorial, and we need to start thinking about a few things. One of them is we're going to start creating your group assignment teams. So we will start talking about that today. We're going to talk about quiz 1, which is next week. And I'm going to talk about the solutions that you already have. Currently, you have solutions for tutorial 1 and tutorial 2 are already available on Moodle for you guys, so you can use them in preparing for the quiz 1. But at the same time, we will be having another quiz happening. So we will be having other things we need to be talking about, including the calculations you need to be doing today, and you need to be learning today. And there's going to be some exercises we won't finish, but you can go and do more exercises at home because I gave you to them, and I'm going to give you a lot of solutions available. So you need to work hard because we have a quiz next week. Do you have any? Yes.
I have a question. It just like, I mean, it's not related what we have studied today, but I mean the parts that we studied, like the A, B, C, D, E. So who is responsible to categorize it? I mean, is it the project manager who categorizes the tasks like that?
The names you mean?
Yeah, I mean the one we did just now, like the merge and then from start to finish.
My friend, here I'm using any names. Okay, in your project,
yeah,
this would be actual task names.
Yeah. Just what. So
yes.
So who's gonna responsible to do that? I mean the
project
tasks.
manager and the project team work together to calculate all of these things. Okay?
Okay.
Not one person, it's a project team work together to get all of this information calculated and the names decided.
Okay, so it's all inside the project management.
Absolutely, it's a team, not simply the project manager, it's a team working together.
Okay.
Make sense?
Excuse me, sir.
Yes.
Yes, sir.
Excuse me, sir.
I can hear you, my friend. Tell me.
Okay, so the calculations we did today, the one with the like early finish, early start, we're gonna repeat this in our tutorial today.
We will be doing them in the tutorial, so yes, you will see them there. You will apply them there today. Absolutely. I won't give you a calculation and then let you fail. I will help you apply it. If you come to the class, you will apply it, and that's why you will not fail my classes, because you will have the chance to learn it and apply it.
Yeah, all right, sure. No worries.
Make
Thanks.
sense?
See you at 7 o'clock.
All right, guys. So now I need you to, for those who are in the 5 o'clock tutorial, I will log out now and log into the other link. So please go there. If you want to ask about your attendance, don't ask me now. I just saw someone who just came now. If you want to ask about your attendance, don't ask me now. Ask me when you go to the tutorial, because you'll be able to see whether I marked your attendance or not. I'll be doing it later. When I mark it, I'll let you know. And then you can check if your attendance is already there. Alrighty?
All right, so
thanks, guys. I'll see you now in the next class. So let's log into the next.
So I'll see you in the tutorial.
See you, mate. Thank you.